Hi, and welcome to today's video. Thank you for joining me today. Today we're going to be talking about equations of parallel and perpendicular lines. So we just talked about, in the previous video, equations of lines. We talked about slope-intercept form and standard form and point-slope form. So we're going to be extending those now and writing equations of parallel and perpendicular lines. So we'll start out with parallel lines. First of all, parallel lines, one thing to know is parallel lines always have the same slope. So if you know the slope of one of the lines, you automatically know the slope of the other line is the same. And the other important thing to know about those lines is they never intersect. So in example 1 here, we need to find the equation of the line parallel to the line y equals 3x plus 4 and goes through the point 2, 4. So again, since we have y equals mx plus b, we have this in slope-intercept form, we know our slope of this line happens to be 3. So we can use that information to write our new equation. Now notice here it just said find the equation. So it doesn't say what form we need to write it in, so we can use any form to write our equation. So my suggestion is use point-slope form. So in y equals 3x plus 4, the slope m is 3. Use point-slope form using m equals 3 and the point 2, 4. So all we have to do, we have our x value, our y value. So y minus 4 equals 3 times the quantity x minus 2. Now, our directions didn't say to put it into slope-intercept form, but just as some practice, we'll go ahead and transform that into slope-intercept form. Just know you don't need to change it to slope-intercept form unless the directions tell you to. So start out with our point-slope equation here. Distribute the 3, so we have y minus 4 equals 3x minus 6, and then simply add the 4 over and we have it in slope-intercept form. So we have y equals 3x minus 2. So notice 3x plus 4, 3x minus 2, they have the same slope in both equations, so they are definitely parallel lines. Okay, next example. Example 1b. Find the standard form equation this time of the line parallel to 3x plus 2y equals 6 and passes through the point negative 4, 5. So this time it is telling us to write our equation in standard form. Before it didn't say what form to write it in, so point slope was fine. But this time we need to rewrite the new equation in standard form. So we do need to find the slope of the original line. So to do that, let's take our standard form equation and rewrite it in slope-intercept form. So subtract 3x from both sides. We get 2y equals negative 3, or sorry, negative 3x plus 6. And then divide everything through by 2. So we get y equals negative 3 halves x plus 3. So our slope is negative 3 halves. That's really the information we needed from that, is the slope. We didn't necessarily need the y-intercept, but that's okay. We know the slope is negative 3 halves. So now use our slope and the point we are given to go ahead and write in point-slope form. So here's our y value. So y minus 5 equals m, negative 3 halves, times x minus negative 4 is our x value. So x minus negative 4. Now remember that trick we talked about. To get rid of the denominator of this fraction here, we just multiply through by that, whatever that denominator is, in this case 2. So multiplying both sides by 2, we get 2y minus 10 equals negative 3 times the quantity x plus 4. And remember, this minus and negative just means plus. Okay, so distribute the negative 3 over here. So we have negative 3x minus 12. And now go ahead and add 3x to both sides. And in the same step, I'm just going to add 10 to both sides just to make it a little quicker here. So we get 3x plus 2y equals negative 2. Notice here, 3x plus 2y is the same as 3x plus 2y in the original problem. We just have a different number here. Well, if we put in negative 4, 5, if we put negative 4 in here and 5 in here, we get negative 12 plus 10, which happens to be negative 2, which is our value that ends up being over here. So kind of a nice little shortcut to learn there. Okay. In example C here, find the equation of the line that passes through 4, negative 2 and parallel to y equals 5. So remember, the line y equals 5 is just a horizontal line, 5 up from the x-axis. So since the slope of y equals 5 is 0, our new slope is also going to be 0. So our new equation is just going to be in the form y equals something. So these problems are actually pretty easy, because if we just look right here, our y value is negative 2. So our new equation is y equals negative 2. Okay, now on to perpendicular lines. Perpendicular lines are lines that intersect at 90-degree angles. The slopes of those lines are always opposite reciprocals of each other. So I'll remind you what opposite and reciprocal are here in just a second. So in example 2, find the slope of the line perpendicular to the line 4x minus 6y equals 12. So once again, in order to do this, we need to know the slope of the original line. So put it into slope-intercept form. Simply subtract 4x from both sides. So we have negative 6y equals negative 4x plus 12, and then divide through by negative 6. So we have y equals positive 2/3 x minus 2. Okay, so since our original slope is 2/3, remember, opposite is simply just put a negative sign in front of it, and reciprocal means we take the fraction and flip it over. So the opposite reciprocal slope will be negative 3/2. So the slope of the perpendicular line is negative 3/2. And that's all we needed to do on this one, just find the slope. Okay, for example 3, find the standard form equation of the line perpendicular to 6x plus 2y equals 4 and goes through the point 9, 2. So we, of course, once again, still need to find the slope. So subtract 6x and divide through by 2, and we get the equation y equals negative 3x plus 2. So our slope is negative 3 for our original equation. So remember, we need to find the opposite reciprocal. And remember, any whole number we can write as a fraction over 1. So the reciprocal of 3 would be 1/3. And since this one is negative, our new slope is going to be positive. So our new slope is m equals 1/3. So write your equation using your point and your slope. So y minus y1, y1 is 2, equals 1/3 times x minus x1, and x1 is 9, so we're going to put a 9 in there. So we have y minus 2 equals 1/3 times the quantity x minus 9. So remember, once again, we need to get rid of the fraction when we're writing in standard form. So multiply through by the denominator of that fraction, which is 3. So if we multiply both sides by 3, we have to distribute the 3 on this side. 3x minus 6 equals 1 times x minus 9. Well, that 1, when we multiply, it doesn't really change the value at all. So it's just x minus 9 down here. So now we just need to solve or put it into standard form. So subtract x from both sides. And while we're at it, let's go ahead and add the 6 to both sides. So minus x plus 6 gives us negative x plus 3y equals negative 9 plus 6 is negative 3. And remember, the other requirement for standard form is we can't have our a value to be negative. So to get rid of this negative here, simply multiply everything through by negative 1. So negative 1 times negative x is positive x. Negative 1 times 3y is negative 3y. And negative 3 times negative 1 is positive 3. So we get x minus 3y equals 3. Okay, and in our last example, find the equation of the line that passes through, once again, 4, -2, and perpendicular this time to y equals 5. Well, since y equals 5 is a horizontal line, our new slope, or our new equation, needs to be of a vertical line. So all vertical equations are written in the form x equals something. And so since the x value in this case is 4, our equation is x equals 4. So that's all I have for you today on parallel and perpendicular lines. Thank you for joining me, and I'll see you again soon.